Hi, my name is Lauren Melcher and I'm an industrial engineering major. Today we have an instructional video about sequences. So when we're trying to find the sequence of two tables, or the input and the output, we need to look for constant patterns or consistent equations. So let's start with this first table on the upper left. We have our, let's say we can call this our input value table. And in the second column we have our output. So a good way to try to find simple sequences that correspond to the numbers in these tables is to use subtraction to determine the pattern. So we see here that 1 minus 1 equals 0, and 2 minus 2 equals 0, and 3 minus 3 equals 0, and 4 minus 4 equals 0. So we see we have a constant pattern, so the value is just n, which is this whole column right here. So let's look at our second table. We see that if we have 1 in this row, then 2 is our output. If we have 2 in this row, then we have a result of 3. So we see that if we subtract 2 minus 1, we're going to get 1. 3 minus 2, we're going to get 1. And 4 minus 3 equals 1. And then 5 minus 4 equals 1. So we see that our equation for this table is n plus 1. So if we have, let's say, a term for n, maybe 6, then the value, which comes on the other side, is going to equal 7. Now let's look at our third table. We see that we have 1 for our interim here, and our value is also 1. We have 2, and then 3, 3, and then 5, and 4, and 7. So if we subtract these, we see that our difference here starts at 0 for 1 minus 1, 3 minus 2 equals 1, 5 minus 3 equals 2, and 7 minus 4 equals 3. So we see that the equation for this sequence is 2n minus 1. So this pattern is actually growing by multiplication. So we can have an example of this right here. If we have 4 as our n term, we'd have 8 minus 1, and that would equal 7. So that works. Now for our last table, we have 1 right here as our n term, and then our value is 3. 2 and then 5, 3, and then 7, and then 4 results with 9. So when we use subtraction to try to find the sequence for this table, we see that 3 minus 1 equals 2, 5 minus 2 equals 3, 7 minus 3 equals 4, and 9 minus 4 equals 5. So we see that this pattern is also growing by multiplication, but instead of subtracting 1 after we multiply the n by 2, we're adding. And let's take this last value on the table. Let's say we have 2 times 4 plus 1. So we know that 2 times 4 is 8, and when we add the 1, we get 9. So this is the equation for this last table. Thank you very much for watching, and keep on learning.